welcome to an algebra video learning about solving systems using the substitution method. Alright, so we're doing another example of solving a linear system of equation here. The substitution method I've got listed out just on the steps here on the right. It involves taking one equation and substituting part of what is equal into the other one. So we're going to run through these steps. If you've watched my previous video, this one's a little bit more complicated, so we're taking one step more difficult, and there'll be another substitution method example right after this one as well. All right, let's go through this one and talk through it. I want to find the solution, the x and y value, to 2x minus 5y equals 1 and x equals 3y plus 4. Again, if I was to graph these two equations, I'm trying to exactly find what the intersection point is of these two lines. All right, so step one, in the substitution method, I need to look for, in both equations, look for a variable that is isolated all by itself. This first one, I got 2x minus 5y equals 1. My x is not by itself. They're both on the same side. It's in standard form. So that's not what I want. It's not isolating variable. But the second one, I have x all by itself right there. And I can see that x is equal to 3y plus 4. All right, so I've got a variable isolated. I'm feeling good. Step one is done. Step two, now that I know x is equal to 3y plus 4, I can substitute 3y plus 4 into the other x right here. It's equal. X is 3y plus 4. And since they're equal things, then I can replace them and rewrite a new equation, substituting 3y plus 4 in place of x. I'm going to put parentheses around this, and I think you'll see why in a second. But let's rewrite my equation. So I'm going to take the top equation now, so I still got 2. But now 2 is being multiplied by 3y plus 4. We substituted that in for x. So it's not 2 times x, it's now 2 times 3y plus 4. But I still got the rest of the equation, so it's still minus 5y equals 1. All right, there we did. We just did the substitution step. What does that do? It lets us combine both equations. So now I just have one equation, and it only has one variable. There's just y. So I can now use all my algebraic stuff. I can do things to both sides. I can rearrange this equation and now solve for y. So that's what I'm going to do. I'm going to solve for one variable. I'm going to solve for the y variable. So let's draw my line down. So I do the same thing to both sides, keep things equal. And I'm first going to distribute. I got this 2 times, I got to multiply that 2 times 3y and the 4. So we end up with 6y, 2 times 3y is 6y, plus 2 times 4 gives me 8, minus the 5y equals 1. So we distributed. Now let's combine like terms. I've got 6y and a minus 5y, so those combine to make 1y. 6 minus 5 is 1, so 1y plus 8 equals 1. And now for my last step, I'm going to subtract 8 from both sides. Plus 8 minus 8, those go to 0, and it looks like y is equal to 1 minus 8, which is negative 7. All right, so in my solution, we just found part of my solution. Where are these two lines going to intersect? They're going to intersect at a y value of negative 7. Now, a lot of times when I see students solve problems, linear system problems, they stop at this point. They're conditioned, or you're used to thinking, okay, I got an equation, I've solved it, I've got an answer, boom, I'm done. And when you're in the stress of a test or a stress of a quiz or on the spot, it's really easy to forget that I have a whole nother variable to find. So we solved for one variable, but I gotta solve for the other variable. I'm looking for an intersection point, an x and a y value, because it's all about that relationship between x and y. So let's take my y value, and here's where I back substitute. I use my y value in one of the equations to solve for x. I'm gonna pick the second one because it's kind of set up a little bit easier to find what x is. So x is equal to, I'm going to take this equation right here. So x is equal to, and let's back substitute. I know y is negative 7, so let's put negative 7 in for y. 3 times negative 7 plus 4. 3 times negative 7 is negative 21 plus 4. And it looks like x equals negative 21 plus 4 is negative 17. All right. So that's the intersection point. If I graphed these two lines, they would intersect at negative 17 and negative 7. So we back substitute, we solve for the other variable. Now it's the all-important step of checking your work. Again, you can do this with a graph. So sketch a quick graph using your calculator or using a computer and just see, does this actually the intersection point right here? Or we can check with the other equation. So we used this equation, x equals 3y plus 4, and we solved for x with that one. But now let's use the first equation and put x and y in and just test it out. So does 2 times x, which is negative 17, we're going to check this point, minus 5 times y, which is negative 7, do they end up actually equaling out 1 when I simplify things out? So 2 times negative 17, let's check it out, is negative 34, minus 5 times negative 7 is negative 35. Well, that turns into negative 34 plus 35 because we have subtracting negative. And yeah, it looks good. It checks out. It does equal 1. So my solution to the linear system is this point right here. When x is negative 17, y is negative 7. That is the point that works for both of these equations.